Okay, problem 9. A random sample of 56 fluorescent light bulbs has a mean life of 645 hours. A mean life of 645 hours. With a standard deviation of 31 hours. A random sample of 56 fluorescent light bulbs, 56 fluorescent light bulbs, has a mean life of 645 hours with a standard deviation of 31 hours. I think they're saying that that is the sample standard deviation, which we designate with S. That's 31 hours. So sigma is what we use for population standard deviation. S is what we use for sample standard deviation. Use this sample data to construct a 95% confidence level. 95% confidence interval for the mean of all such light bulbs. A is 1 minus our confidence level, that's 0.05. A over 2 is half that, 0.025. And so our critical value is going to be negative, INV normal. Okay, they threw us a curveball. We can't use the INV norm because we can't use the normal distribution. And the reason why we can't use it is because we don't actually have the population standard deviation. All we got is the sample standard deviation. And when you don't have sigma, you have to use the t distribution. So let's get rid of all this. Let's see. E is going to equal, okay, so this just becomes S. Oh, and instead of using Z sub A over 2, we say T sub A over 2 to signify that we're using the T distribution instead of the normal distribution. So this is going to be a T score, not a Z score. Now, depending on what type of calculator you have, if you have one of the more advanced calculators like a TI-84 Plus, I think it might be called, you can use the, I think it's TINV, or maybe it's INVT. It might be INVT, I'm not sure which one. And that's just like that INV norm, only it's going to give you the T score instead of the Z score. I don't have that type of calculator, so I'm going to try to do this using a different method. It's going to be the T interval. Basically just calculates the interval for you. So let's see if I have enough information to do that. Say you go to the stat button, and then at the top you have 3 columns or 3 categories. You arrow over to tests, and then that gives you a list, and you select number 8 within that list. And within that list, it shows you on the second line, it has input, colon, data, and then stats. You want the cursor to be on stats. You want that one to be flashing. If this one's flashing, you have to use the arrow button to go over here and press enter on it. And when you do that, what shows up below here is X bar. And this is where you input data. Your calculator might already have numbers in there from previous stuff, previous calculations, but we'll be putting in new values here most likely. And then at the bottom they have sea level. and then calculate. We're going to put here 645. S sub x is this one. We'll put 31. And then n is 56. Sea level is 0.95. Once you input all that information, let me go ahead and do that. 645, 31, 56, and then 95 is our confidence level. Then you use the arrow buttons to highlight, calculate, get that to be flashing. And once that is flashing, then you can hit the enter button, and it should calculate from all that, your interval. And so this is what it puts out on the next screen. 636.7, comma, 653.3. So it's 636.7. I don't know if I said that a while ago. And then it repeats, what x bar and s of x is and n. But I don't need to put those there. All I'm interested in is that second line. So let's see if that's one of my answers. 636.9 to 653.1. Don't know what the discrepancy is, but I'll go for it. I'm going to say that's the answer. So if you're going to use your calculator, and if you're going to use this t-interval, you're going to have to know x bar, your sample standard deviation, n, and your sea level. You need those 4 pieces of information. These 4. Punch those in, and it'll give you your interval. If you run into a problem on a quiz or a test that wants you to find t sub a over 2, you'll either have to learn how to use the chart, which is on the chart's on page 321 in chapter 8. So you'll either have to learn how to use that, or if you have one of those fancy calculators, you can use the INVT function on your calculator. So it's just like that INV norm, only it's for the t distribution.